let's try to find the reason what are the performance evaluation and rules to be followed for higher performance in .NET application or application like cloud or cloud-based web services prepared using .NET framework. Okay, so these are the things we should try to find the, at least try to find the way through which we can evaluate the performance. We can evaluate the performance and we can also try to find some rules and some thumb rules for future optimization, or at least prevention of any performance performance hit in your application and service, right? So this is the two key things we should try to focus in this session. So this is Vinod Mohan, and he has explained top 7 performance problems in .NET application and how to solve them. Let's read it, okay? So Microsoft .NET framework is one of the most popular application development platform and programming language. C# and ASP.NET framework are used by millions of developers for building Windows client application, XML web services, distributed components, client server application, and so on and so forth, right? So let's choose this format, okay? So, and web services, distributed components, client server application, so there can be numerous reasons why .NET application can be slow. So these are not perfect things, right? These are not exactly this will happen, but these are the probabilistic thing. So that is what author is writing here. These includes incorrect memory sizing, GC pauses, code level errors, excessive logging for exceptions, high usage of synchronized blocks, IIS, server bottlenecks, and so on. So this seems to be some generic, but of course this is related with experience, right? So this seems to be like some senior engineer is just saying generic thought as of now. Okay, let's move on. In this blog, we will look at some of the top performance problem in .NET application and provide tips to troubleshoot and resolve. So the one thing is that identifying the problem area in performance, for performance is also a good skill for experienced engineer, right? So, and most of the time in real time environment, we have to understand the performance bottleneck, and then we also have to know how to work around with these performance bottleneck. What would be the long-term solution to avoid these kind of performance bottleneck? Okay, so that is two important things. One is identifying it, and the second is how to work to solve on this for a longer term, right? So like design-centric solution for this problem. Okay. All right. So as the author mentioned already, they are trying to focus on top 7 reason of performance bottleneck and their probabilistic solution or approach, at least, right? So here the first thing is that the first problem as such is exception and logs one too many. So like if your system have many unhandled exceptions or too many logs, then that will degrade your application performance. So this is a common reason usually when any team which is very naive or not that much expert people, the part of that system, or maybe code review or like mentoring session is not proper in the team, then in that case these kind of because these all happen with some assumption, like when you are working on distributed system, the only friend you have is logging, or traceability of your implementation. So usually this is misunderstood by developer, and they are trying to log everything, and that will sometimes create the performance challenge for the system. So that is also, code reviewer or senior engineers' responsibility here is to put some check on these kind of things. Okay, so yeah. So now, what would be your troubles? How you will, identify, or how we can able to work, find some, like what would be the helpful tips from troubleshooting tips from you will get from your mentor or senior engineer. So his suggestion is following, right? His suggestion is following. The first suggestion is make sure your C# code has try, catch, and finally block to handle exception. So do not leave any code or block which is not properly handling the exception, because that will introduce extra level of burden in your application, right? So make sure your C# code has try, catch, and finally block to handle exceptions. The second point is leverage exception filter available in C# 6 and above. So if you are working on C# 6 and above, you should always leverage exception filter available in C# 6 and above, which allow specifying a conditional clause for each catch block. Okay, so conditional clause for each catch block. So this is another good point, and I'm pretty sure that if you follow it, this is a good suggestion. But if you are still using the older .NET framework, then probably this is not the this function is not available in your code base. But otherwise, you should you can move ahead with this. Okay, check for null values and use try parse to avoid potential exception. Check for null values and use try parse to avoid potential exception. What is this? Let me share you once I start the writing some sample code for these kind of suggestion. Okay, so I will start after that. First we should go through all these 7 ideas shared by the senior engineer, and then we will try to put into the code perspective. Okay, Now next is pay attention to second chance exception, as these indicates that the first chance exception came up and it was not handled properly. So pay attention to second chance exception. I mean, let me try to further dig dive what exactly author is trying to say here, because there is no example given by author. So I will try to little more dig dive, and then I will come with some sample where I can demonstrate this. Okay. Now use exception handling and logging libraries such as enterprise libraries nlog, serilog, or log4net to log exception to a file or a database. So this is very handy suggestion, because without this you cannot work on any distributed system. Logging is the fundamental requirement of distributed system, where you can trace out your tracing model or trace out your code flow easily, and then after that you can say that, okay, I have done this, I have done that, and like that, so on and so forth. Okay. So yeah, use exception handling and logging libraries such as nlog, serilog, or log4net. Okay, so I have already explained you. So, most of the industry is using log4net, but like it depends like how much you are comfortable with which log. But anyway, these three options are primarily nlog, serilog, or log4net. Okay, make sure you log exception only as much as needed and not end up blotting the log file. So you should not log every exception, right? You should not log every exception, because making log to every exception is little bloating kind of things, right? So you should try to avoid. So okay, I believe that yes, this is correct. So make sure you log only which is necessary or required in case of exception. Not every exception should be logged. There is no fundamental any thumb rule that every exception should be logged. It depends on exactly what is your requirement, right? Because logging of every exception is actually creating a blotting kind of concept, which will degrade your application performance as such in the longer run. Yeah. The second suggestion given by this senior engineer, this fellow, is overuse of thread synchronization and locking. So as you know, thread synchronization, like synchronization between the threads, is not free of cost. It is always coming with some performance degradation. So it definitely going to hit your performance of your application, right? So overuse of thread synchronization and locking is definitely a bad practice. You must assure that you are putting under this thread synchronization block those chunk of code which is really required synchronization. If something which don't require synchronization, please try to avoid thread synchronization and locking for that code of block. Okay, so this is another thing I would say. So the second point is definitely overuse of thread synchronization and locking is a problematic for performance of your application. So this is second part. And if you go through the troubleshoot tips, helpful troubleshooting tips for this identification and other purpose. So the first is first suggestion given by this author is use synchronized coding and logs only when necessary. Please understand, use synchronized coding and logs only when necessary. Understand the need of the code execution before deciding to use logs. That is what I also explained you. You have to understand where you should put minimum area where you want to put some critical section execution. You should do this only on minimum required area. You should not put every code inside these kind of synchronized block. Otherwise, because synchronization is always coming with penalty of extra burden, right? Extra things required to manage the thread synchronization. And this is as you know already, this is only done by using something which is I would say what should I say, in case of thread synchronization, these things are with the locking concept, right? You can lock some thread, you can allow some thread to execute, and that way you can able to synchronize the threads. So this is definitely going to put some additional performance cost on your system. Scope the duration of logs optimally so that they are acquired late and released early. Scope the duration of log optimally so that they are acquired late and released early and does not hold other threads in wait for a long time. To reduce concurrency issue, consider using loose coupling. Event delegation model can also be used to minimize log contention. So to reduce concurrence issues, consider using loose coupling. Event delegation models can also be used to minimize log contention. Monitor the .NET code using code profiling tool to identify if thread locks are causing slow application processing. So monitor the .NET code using code profiling tool. Okay, so these are the 4 beautiful suggestions given by this author, right? These are the 4. Okay. So the first is use of a synchronization very judicially. Scope of the locking or duration of locks optimally. Third is, as I explained you, consider using loose coupling. If your multiple component have many coupling, then definitely it will create such kind of synchronization of such kind of code block requires extra attention, and which is definitely going to put penalty or in terms of time. Okay, and then there you definitely use some of the profiling tools. You should use some of the profiling tool to further dig dive, and these profiling tools are like .NET monitoring. Okay, so .NET transactions, analyze distributed server side. So optimize digital user experience for .NET web app. So application performance monitoring will be done by like optimize digital user experience for .NET web app. These are the tools. I will not, most of them I don't know right now, but I will try to get the at least understanding. First I have to know it, and then I will try to dive little more. So in future videos, I will try to explain what are these tools is doing and how exactly you can use it, what kind of benefit you will get. So the first thing is optimize digital user experience for .NET web apps. Okay. The second is analyze distributed server side with .NET transaction. Then gain deep insight into .NET code and identify errors. In-depth monitoring of .NET framework, CLR and IIS. This is something done here. Something shown here also. Deep visibility of .NET framework. Troubleshoot faster with automated root cause diagnosis. So like if you look at this root cause diagnosis tool, so here it is clearly showing that. So this is informative, and these have no problem. But here it is challenging. Like so, Microsoft SharePoint 2010 and 2013 is creating a challenge for us. And then Microsoft SQL SharePoint DB is actually a slow here. This is real slow. So due to that, Microsoft SharePoint is also getting impacted, and so on and so forth on the upper layer, right? So this is what this method is explaining. This article is saying to you. Now, application performance monitoring for all stakeholders. Application owner. So there are different owners of the different part of application development, right? Application owner, who is actually developing the application. IT administration team, who are actually managing the complete infrastructure requirement, and then user interaction for that system, right? So this is another kind of. All right, let's start again the discussion. So for now, I think we already gone through that these tools. Quickly, let me go through more. So it is something like application performance monitoring here going on. For all stakeholders, like application owner can detect user experience and application performance issues. IT administration team can drill into any component like .NET, IIS, SQL Server, AD Cloud, etc., and gain deep performance insight for troubleshooting. So DevOps teams can proactively identify performance bottleneck and ensure faster production rollouts. Then developers benefit from quick identification of code level and database query level errors, and help desk personnel can quickly view the entire .NET service performance at a glance, pinpoint problem areas for faster escalation. So these are few things which is definitely will help you, right? And okay, so let's close it. These are some tools and tips for you. So okay, one thing you will do that you just cache this page for future discussion. So let's cache it. I will go through again with these tools, and so that I can able to find much more information related to this topic. Okay, as of now I think fair enough to understand this much. Okay, let's move on. So the third is dreadful application hangs. So this is really challenging, right? Hanging of application. If the person who are already working in industry, he can definitely know this concern. And most of the time, when you are working on distributed system, we have a challenging scenario here of like application taking lot time. But in your code, you are not able to see much. You could not able to find any. I mean, most significant reason in your code. Then what you will do in that scenario? When a specific URL is slow, it is one thing to handle. But when the IIS website just hangs and all or most web pages take forever to load, it could not get any worse than this. Yeah. Typically, when an application is overloaded or deadlocked, a hang could occur. There are two types of application hang scenario that .NET application usually encounters. These are called a hard hang, that is the IIS issue. This usually happens at the beginning of the request processing pipeline. So this usually happens at the beginning of the request processing pipeline, where the request is queued. Because of an application deadlock, all available threads could get blocked, causing subsequent incoming requests to end up in a queue waiting to the service. This can also happen when the number of active requests exceeds the concurrency limit. Configured on the IIS server, such as hang, will manifest as request getting timed out and received 503 service unavailable errors. A hard hang affects all URLs and that whole web application itself. Okay. Helpful troubleshoot tips given by this engineer is like this, and I think this is very meaningful if we can follow it. Yeah. So let's highlight it again. Constantly track number of requests in queue in the IIS server. Constantly track number of requests in queue in the IIS server, HTTP service request queues, arrival rate in Windows performance monitor. This should never exceed the request processing limit configured for the worker process. Wait, so let me rephrase let me speak out again this point. This is very important point actually. Constantly track number of requests in queue in the IIS server, and what are those requests? HTTP service request queue. So HTTP service request queue should be clearly monitored, required monitoring here. Okay. Then also try to get the understanding here that what would be their arrival rate, like at what rate HTTP service request arriving in this queue. Because if this queue is getting more and more at a very fast rate, then also this will create a performance issue, right? Because your request is in queue, but you are not able to process this request very fast because of end failure reason, because of failure reason or retry reason, you are not cleaning your queue. In that case, also it might create a problem. But this will only can be proved using these kind of performance monitoring solution services, right? So we have to monitor the performance here. The second point given by this author is that also track how long requests are waiting in queue. Okay, so at what rate it is coming, and then what is the average time the request is staying in this queue. Okay, so if it is staying longer, it means that the processing speed is not fast, and then this won't be your development issue. It might be your infrastructure issue. So in that case, maybe you need to scale your infrastructure so that a queue limit will be down, right? So that the fast execution of fast cleaning of queue is will happen, right? Otherwise, if it is staying longer time and you could not able to process fast, that means your system is not performing well, or somewhere it is a problem based on infrastructure or overall infrastructure. Whatever the prepared here might be insufficient for these kind of loads. So in that case, the one key observation could be you should scale the infrastructure. Okay, so the next is also watch out for service unavailable and connection timeout error by monitoring IIS server events. Okay, so you should also focus on that. So another section here is a soft hang of ASP.NET issue. So I can skip this because this might not be much helpful, but soft hang is something they have mentioned that verify whether IIS is the issue or not by checking the HTTP service request queue again the same way. If it is not an IIS issue, it must be a code level problem in ASP.NET control page. So one is literally more focused on the IIS service queue, and the another is based on how you have written your page. I mean client side code, which is more or less is doing how you have written the controller code or page code in ASP.NET. So for me, like more focus would be in that HTTP service request queue only, because that will make more sense in case of backend service. Okay, so I will try to focus on that only first as of now. All right, so let's moving on to like frequent garbage collection pauses. So what is this? Especially the language, higher level language like Java, .NET, C#. These both have garbage collector. And garbage collector is something which is doing some of the help in your application out of the box, right? If you look at like your background, like my background is from C++, where there is no garbage collector kind of things. So what we are doing over there, that either we have to use memory and free it once done. So we are cleaning our own garbage there, or we are trying to make some memory pools where you can share these memory as much as possible, so that you don't require to cleaning in between or lot many frequent times. So that might be one way of solving this frequent garbage collection thing, I believe that. But let me go through what exactly the problem engineer is mentioning here and how they are solving, what kind of tips they are giving to solve it. So garbage collection in .NET CLR is initialized when the memory used by the allocated object on the managed heap exceeds an accepted threshold configured by the application developer. So okay, so let me repeat again. Garbage collection in .NET CLR runtime is initialized when the memory used by the allocated object on the managed heap exceeds the accepted threshold value configured by the application developer. So this thing I need to check how you can, as a developer, you can set this threshold value for your application, and that could be one way to like debug or improve your application performance, right? So I can see this thing. The another point he has mentioned that this is when the gc.collect method jumps into action and reclaim the memory occupied by dead objects. Okay, so yeah, so the basic fundamental rule of garbage collector is you are just when you are done with memory uses or object, you are just making sure that you are notifying garbage collector, okay, I am done with this object, you can collect. Now it is not necessarily required thing that garbage collector immediately collect the memory and move ahead. That is not the obvious way to implement it. So what they make sure that once they have time, or they think that now let's go for the garbage collection, at that time they are just checking their reference, their registration table, right, registered table, that what are the dead objects inside the application, and then one by one they are collecting the dead objects. This is what the typical garbage collector is working. So GC in the CLR usually happens in generation 0 heap, where short-lived objects are stored. It is called full GC when GC happens in generation 2 heap, where long-lived objects are contained. Every time GC happens, it add a lot of CPU load on the CLR and slow down application processing. So in the event of longer and more frequent GC pauses, the application tends to suffer slowdowns. So in the event of longer and more frequent GC pauses, the application tend to suffer slowdown. Helpful troubleshoot tips is size GC heap memory properly. So you have to size GC heap memory properly and make sure GC limits are set as required. Avoid using objects and large string where they are not needed. track instances of GC, time taken by GC, and percentage of GC time spent by the JVM. Looks for times when full GC happens. This can cause application slowness. Looks for times when full GC happens. This can cause application slowness. Judicially use server GC or workstation GC based on application needs. Okay, so monitor the CLR layer end-to-end to identify memory usage, GC activity, CPU spike, etc. So these are the suggestions given by engineer for handling this application type of, hangs, right? Not application hang, it's a frequent garbage collection pauses. So how to avoid these frequent garbage collection pause? Because if you do so, then it is like garbage collection pauses and restart is actually giving lots of overhead on your system, and eventually that will impact your performance on yours. It will impact performance of overall system, right? So we should be very careful for this thing. Okay. So, and the points here, they have mentioned that your size of GC heap memory is properly defined. You should assign the limit properly. Then avoid using objects which is large, or maybe large size strings. So try to avoid large object or large size string like that. So that if it is not needed, don't do it. But if it must require, then think on that that way, like how to reuse this thing again and again. Don't create new memory every time. So if it is necessary, then also you have to check that optimization. And if it is not necessary, of course, don't use it, right? The third is track instances of GC in terms of time taken, percentage of the GC time is spent by the JVM. So yeah, so I have to look around this more, because garbage collector is the real pain area in these higher languages, just like a .NET, C# or Java. So that may be a good reason to creating a slowness which is random also, right? Just like I have seen that many times it is happening, lots of random situation, right? So this may be one of the key reason behind it. Then looks for time when full GC happens. This can cause application slowness. Okay, so another key area is look for the time when full GC happening, because full GC, complete garbage collection, is always a time taking job. So if it is happening too frequently, then that would create an extra burden of performance on your system, and which will slow down the actual task. Okay. Judicially use server GC or workstation GC based on application needs. So it's not like random behavior you have to show. You have to show behavior which is more meaningful for you, right? So judicially use server GC or workstation GC based on application needs. And then the last one is monitor the CLR, monitor the runtime layer end-to-end to identify memory uses, GC activity, garbage collector activity, CPU spikes, etc. So monitor the CLR layer end-to-end to identify memory usage, GC activity, CPU spikes, etc. So yeah, this is the another thing you have to. So these are the valuable suggestions. I will try to understand how we can do it, but this is definitely going to be a valuable suggestion, right? Then the next thing is, and this is also a very specific reason behind it. And so this is something like IIS, server bottlenecks. And how it is happening, that Microsoft IIS server is a critical part of the .NET framework. Okay? So Microsoft IIS server is a critical part of the .NET framework. So IIS is the web server which hosts the web application or website built on .NET and runs W3WP process that is responsible to respond to the incoming request. IIS also incorporates the common language runtime, CLR, okay, common language runtime, which is responsible to meet our resource for thread processing, because IIS has various moving parts. A bottleneck in IIS could have a direct negative impact on the .NET application performance. So please note that this is very important information given by this engineer, that IIS has the various moving parts. A bottleneck in IIS could have a direct negative impact on the .NET application performance. Now let's discuss what are the commonly faced IIS server problems. So let's discuss these problems, right? Commonly faced IIS server problems. The first one is server overloaded due to overutilization of resource such as memory, CPU, etc. Okay. So this is the first point, server overload due to overutilization of resources. The second thing is high concurrent connections and connection drops. So please note down, if your connection drops is too frequent, it will introduce another level of performance hit in your IIS server. So that would again could be a problem, challenging for you. Then application pool failure. Fourth is expiry of SSL certificate. Sometime, but it introduce like extra burden, because for example something is SSL certificate is expired, then they have to check this SSL certificate, and then again retry mechanism is also introduced. So those all together create a performance issue on your application. Okay, high response time of the ASP.NET request handling services. So I think I will skip this. Then high CLR wait time, common language runtime, improper caching, and then HTTP errors, including a static and dynamic content error and connection errors. So HTTP errors like static and dynamic content errors, these errors like connection error, these all are introducing many retry, and those retries eventually putting extra uh, time required to perform the system, and that would create a performance issue for your system. So these things need to be monitored properly. Okay. Now author has suggested some helpful troubleshoot tips here, and these tips are: right size the IIS server so there is no resource contention or overutilization of resources. Load balance with more IIS server based on rate of incoming request. Load balance with more IIS server based on rate of incoming request. Track SSL certificate validity and get alerted proactively before a certificate expire. Monitor all aspects of IIS in performance, application pools, websites, and identify improper configuration and performance deviation. Okay. So these are the tools for IIS server bottleneck. Okay. So I think this is good idea, but not sure what are the common challenges here, but or we can able to solve these challenges by this way or not. We will verify it later, but for now this is the helpful troubleshoot tips for IIS server bottleneck, and those are, let me repeat again: right size the IIS server so there is no resource contention. So right size the IIS server, load balance with more server based on rate of incoming request. So as per the request, if it is coming very highly rate with high increment rate, then definitely you should pump up more IIS server here, so that load balance should handle properly here. Track SSL certificate expiration validity so that this extra because of certificate expired, this will not introduce extra burden in your performance. And the fourth one is monitor all aspects of the iOS performance, application pools, website, and identity proper configuration and performance deviation. These all should be monitored well so that we can track properly. Okay. And then slow database calls. Sixth is, which is very, very important. Yes, it is important. So, but it depends on which database you are using and how much load your database is getting due to this. Okay. So it is not always a .NET, right? It is not always a .NET code issues that is significant application performance. Slow running queries are often a common cause, but it is usually the .NET application developers who get blamed for slow application performance. The reason for this is there is no contextual visibility of how SQL performance affects. Now .NET application processing, Ado.NET and Ado.ODP.NET connectivity issues could be one reason to query processing slowness, but the common reason is that the queries are not well formed, improper creation, plans, missing indexes, poorly designed schema, small buffer pools, missing joins, improper caching, connection not being pulled properly, etc. are also a reason why query processing by the database could be affected. Alright, so slow database connection is really a challenge sometimes, but when you use some standard database like Oracle, probably this is less possibility, but anyway, it is not completely ignored also, right? So we should be careful for this, but not completely dependent or not completely ignorant of this thing. So there is a possibility of slowdown, of slow database call, but if you are using very standard solution, like a standard brand solution in database, then yes, you can think the last option here. If nothing is working, then we can think of it. Okay. So yeah, now there are chances, many times it is possible that issue is for, like, this is the seventh problem, right? Seventh reason behind the issue, performance issue. And this is also a very generic, but yes, we have to prove somehow. .NET Framework is not a standalone tier. An application using .NET Framework will have many dependencies with the underlying infrastructure, such as any virtualized server, containers, or cloud infrastructure. Then there could be backend storage devices, while these are not .NET problems directly. But a problem in any of these infrastructure components could affect .NET performance just the same. So as an example, if I have to answer your question, just like how we saw IIS server and database could have bottleneck, a virtual machine could be running out of the resources. A SAN array could be experiencing high IOPS that it cannot handle, or if the .NET application is hosted on Azure, there could be an app service that is not running properly. So any example like that, okay? So just like how we saw, so these are any possibility, right? So in that case, like network related complaints top the chart in most application environment. There is always the blame game between whether it is network issue or the application issue. Network congestion, packet drop, or device failures could impact application performance and connectivity. So the next helpful troubleshoot tips for you is that total performance of the network .NET application depends on many factors, right? As the author has already mentioned. So right. So make sure you implement a converged application and infrastructure monitoring strategy to catch infrastructure issue. Most of the time, if you are not implemented or you are not taking care to the infrastructure issue, then in that case, lots of issues directly coming to your application structure or architecture, though it is not related with your code. So that's why it is better to think on it properly again and then try to find the right solution. So I'm ending here because this is a good blog actually, and I think I will explore further on this line. This seems to be some valuable feedback here, and I hope you like this discussion. Thank you. Thanks a lot. Have a nice day.